Welcome to the Explainer. I want you to imagine a library, but not just any library. This one contains every single living thing on our planet. Today, we're on a quest to find the catalog for this grand, beautiful, and kinda chaotic library of life. So let's start with a number, 1.8 million. What is that? Well, get this. That's how many different species we humans have managed to identify and give a name to so far. From the tiniest microbe to the biggest blue whale, that's how many books we've officially put into our planet's library.
But just imagine walking into a library with nearly 2 million books just scattered everywhere. No system, no sections, no catalog. It would be total chaos, right? Well, that is the fundamental challenge of biodiversity. How on earth do you even begin to make sense of it all?
And this library isn't just big, it's unbelievably diverse. I mean, you've got single-celled organisms that live in volcanic vents. You've got bizarre, complex animals in the pitch-black deep ocean. And you've got plants that somehow survive in the most scorching deserts. The sheer variety is just mind-boggling. All this variety creates a massive communication problem. You see, what we call a dog in English is a kutta in Hindi and a perro in Spanish. If scientists only used these common local names, they could never be sure they were talking about the same creature. For science to work globally, it needs a universal language. Now, if there's one thing we humans are pretty good at, it's trying to create order out of chaos. Scientists desperately needed a solution, some kind of standardized system to classify all of life. And the breakthrough? Well, it came from one person, and it would change biology forever. And here he is. Let's meet the librarian of our story. A Swedish botanist from the 18th century named Carolus Linnaeus. He's known as the father of modern taxonomy for a very good reason. He's the architect of the basic system we still use to this day. In his groundbreaking book, Systema Naturae, Linnaeus basically invented the card catalog for the library of life. He laid out a logical, consistent method that could be applied to any organism anywhere on the planet. It was truly revolutionary. Linnaeus's system is brilliant because it has two key parts. First up, the naming system. This is how every living thing gets a single, unique, official name that scientists all over the world can recognize. He called it binomial nomenclature. Now, that sounds fancy, but it literally just means a two-name system. The idea is both simple and totally elegant. Every single species gets a unique, two-part scientific name. This makes sure that no matter what you call it in your local language, it has only one official name. Period. And to keep things from getting messy again, this system has 4 strict rules that everyone follows. First, the names are in Latin, or at least Latinized. Why? Because it's a dead language. It doesn't change. Second, each name has 2 parts, the genus, which is capitalized, and the species, which is lowercase. Third, you always write it in italics. And finally, as a little nod to the discoverer, you can add the name of the scientist who first described it. Let's take the mango, for example. Its official scientific name is Mangifera indica Linn. So Mangifera is the genus that groups it with other plants that are like mangoes. Indica is the specific species. And that Linn at the end, yep, that's our guy, Linnaeus. It tells us he's the one who first named it. It's simple, it's packed with information, and it's universal. Okay, so now every book in our library has a unique, unchangeable title. That's a huge step, but where does it actually go on the shelves? This brings us to the second brilliant part of Linnaeus's system, the Great Filing Cabinet of Life. It works almost exactly like a postal address. You know, you start broad with a country, then get more specific with a state, then a city, a street, and finally, a house number. Biology uses this same idea of a nested hierarchy. It gives every single organism a precise address in the grand scheme of life. These levels are called taxa. You start at the bottom with the most specific unit, the species. From there, you group related species into a genus. Then, you group similar genera into a family. Families into an order, then a class, then a phylum, all the way up to the biggest, broadest category of them all, the kingdom. With each step you take up that ladder, the groups get big. This whole hierarchy creates this really elegant trade-off. As you climb up the ladder from species to kingdom, the groups get way, way bigger, but the organisms inside them share fewer and fewer things in common. It's just a really powerful way to see both the nitty-gritty details and the big picture connections of all life. So let's actually see this in action with a few examples. Look at us. We're Homo sapiens. We're in the genus Homo, the family Hominidae, and so on up the chain. But what's cool is that the exact same structure works for a mango, Mangifera indica, or even a housefly, Musca domestica. Everything, no matter how different, has its own specific place in the system. So we have this amazing system. We've got a universal name and a cosmic address for everything. But let's ask the big question. Why does any of this actually matter? What's the point? It matters because the whole goal of classification has changed over time. Early systems were artificial. They just grouped things by convenience. Let's put all the red flowers over here. But modern systems are phylogenetic. The goal isn't just convenience anymore. It's to reflect reality, to group organisms based on their shared evolutionary history. This deeper science has a name: systematics. It's not just about slapping labels on jars anymore. The real purpose today is to try and reconstruct the actual family tree of life, to uncover the hidden story of how every living thing is connected to everything else. And what's really cool is that this science is always getting better. For instance, the legendary 20th century biologist Ernst Mayr helped redefine what we even mean by a species. It's not just about two things looking alike. The real question is, can they actually interbreed in nature? It just goes to show how science is always refining and improving our understanding. So in the end, this grand catalog of life is absolutely fundamental to modern science. It's the framework that allows us to track evolution, to identify new species that might hold the key to new medicines, and critically, to make informed decisions about how to protect our planet's incredible biodiversity. And this brings us right back to our library. Because here's the most incredible part of all. We've only explored a tiny, tiny fraction of the shelves. Scientists estimate there could be tens of millions of species still out there, just waiting in the undiscovered corners of the world to be found, named, and understood. We started with that number, 1.8 million known species. But it's so clear that the story is far, far from over. The library is still growing. Every new discovery adds another unread book to the shelves. So the only question left is, what will the next chapter reveal?